In this lesson, we're going to ask ourselves, how do I compare, add, and subtract fractions and decimals with unlike denominators? So first, before we get into unlike denominators, I want you to think about equivalent fractions. Equivalent means equal to. So take a look at A, B, C in workbook page 103. Each of these fraction bars shows a fraction that's equivalent to 5/6. So, obviously this first one you can see is 5 out of the 6 sections, 5/6. Well, do you notice how in each of the other bars the same amount is shaded in, the same yellow space is shaded in? They all represent 5/6, but they're broken up into different sections. For example, look at A. You can see that A is very similar to the first one, but it looks like each of the sixth was broken in half. It was split into 2 equal parts. Now we have a total of 12 sections in the whole bar. And of those 12 sections, 10 of them are shaded in. That means 5/6 is the same as 10/12. And if you look here, you can see 5 times 2 is what gives you 10, 6 times 2 gives you 12. There's your 10/12. You can just take 5/6 and multiply the numerator and the denominator by the same number. Now look at B. What if we took each of these 6 from the original bar and we broke them up into 3 equal sections? Well, now you have a total of 18 different sections. So imagine now 15, we started with 1 all the way up to 15, now we have 15 out of the 18 sections shaded in. That tells you that 15/18 is also the same as 5/6. And you can see that here with the multiplication. Multiplying the top and the bottom by 3 will change 5/6 into 15/18. C. Now what if we took each of these 6 that we had at the top and we broke them up into 4 equal sections? Now we have a total of 24 sections, and of those 24, 20 of them are shaded in. So 5/6 is the same as 20/24. We just took 5/6 and multiplied both the numerator and the denominator by 4, and now we have 20/24. So every single time, all we would do is, we'd split them up into more parts, making smaller parts. That's all, more but smaller parts, and they're all still equal to 5/6. Now, that's just one way to make equivalent fractions, to multiply, to make more but smaller parts. The other way to do it is to divide, to make fewer but larger parts. So what if we started with 10/12 this time? You could divide the top and the bottom by the same number, in this case 2, and you can see that's how you can go back to the 5/6 that we had originally. So 10/12 is equal to 5/6. All we needed to do was divide the top and the bottom by the same number. So that's another way to go about this. Either way, you're doing the same thing to the top and the bottom. Either you're multiplying by the same number or you're dividing by the same number. You can also use a multiplication table to find equivalent fractions. Take a look at the 5 and 6 row in this multiplication table. You will see all the fractions that are equivalent to 5/6. Here's 5/6, and look, there's the 10/12 that we saw on the last page, the 15/18, the 20/24, and we could keep going. We could go all the way up to 45/54. These are all fractions that are equivalent to 5/6. We can do the same thing, but with maybe 3/5. This is number 1 at the on page 104. So what if I did, let's see, here's 3/5. So another equivalent fraction would be 6/10. Just going to go straight across the rows. 9/15 would be equivalent. So would 12/20ths, 15/25ths, 18/30ths, 21/35ths, 24/40ths, and 27/45ths. So that's just another way you can get equivalent fractions. Use your multiplication table to help you. All right, now we're going to do some addition and maybe some subtraction with fractions and decimals that don't have a common denominator. Now, if you remember from the last lesson, when we added, we always said, yeah, add the numerators, not the denominators. Keep the denominators the same. Well, what if the denominators aren't the same? We're going to have to figure out a way to make them the same. We have 4/5 and we're adding 3/10. And again, notice I like to write them vertically. You have that option. You do not have to do that, but that's something I like to do. So it says to compare, add, or subtract two fractions when the denominator of one is a factor of the denominator of the other, change the fraction with the lesser denominator to an equivalent fraction that uses the greater denominator, meaning that 5 is a factor of 10. You probably know 5 times 2 is going to give you 10. 5 and 2 are factors of 10. So we're going to use that idea to rewrite 4/5 into another fraction that's equal to 4/5, but is going to have that denominator of 10. You know 5 times 2 gives you 10. Do the same thing to the top, right? Whatever we do to the top, we do to the bottom. I'm sorry, whatever we do to the bottom, we have to do to the top. And we get 8/10. 4/5 is equal to 8/10. And now we have denominators that are the same. We have 8/10 and we're adding 3/10. 8/10 plus 3/10 gives me 11/10, which if I turn into a mixed number, I'm going to get 1 and 1/10. Take a look at example 2. To compare, add, or subtract decimals with different numbers of places, put zeros on the end of the decimal with fewer places to make the number of decimal places in the two numbers equal. So if you remember, we've done this before where I showed you that all you need to do is add zeros so that you have the same number of digits. And now it's going to be easy to add them. 0 plus 3 is 3, 2 plus 0 is 2, 0 plus 0 is 0, and you bring your decimal point straight down, and now we have 23/100ths. So just add zeros on so that each number has the same number of digits. All right, let's take a look at some other examples. Number 4, now we're comparing decimals. Remember, same as adding and what we had done in the past, add add zeros so that each number I should say, has the same number of digits. I'm getting all confused here. So all I did was add a 0 next to the 1 so that now both of my numbers go to the hundredths place. And now I can compare them. Obviously 10 hundredths is going to be greater than 6 hundredths. For number 5, notice I have 2/5 and 8/15. I don't have numerators that are the same. I don't have denominators that are the same. And I only know the rules for comparing fractions when at least one of those things is the same. So what I'm going to do is I'm going to find a way to make the denominators the same, just like I did on the last screen where I had to find a common denominator for 5 and 10. I know that 5 is a factor of 15 because 5 times 3 is going to give me 15. So I can apply that idea. 2/5, if I were to turn that into 15ths, 5 times 3, oops, there we go. 5 times 3 is what gives me 15. I'm going to do the same thing to the numerator, and now I end up with 6/15. So 2/5 is the same as 6/15. And now, because I have the same denominator, it'll be a whole lot easier to compare these. 6/15 is less than 8/15. Now, one other option that I can show you, this is a really cool trick that works for comparing fractions. When you're comparing two fractions, the best and quickest way to go, in my opinion, is to cross multiply. If you don't want to find common denominators, cross multiply. 5 times 8 is going to give you 40. I always write the number at the top. 15 times 2, I start on the bottom, work my way up diagonally. 15 times 2 is 30. And again, I write my number at the top. Now compare the two products. 30 is less than 40. Therefore, 2/5 is less than 8/15. So that's another strategy that you can use when you're comparing fractions. And it works for any two fractions you're comparing, whether they have the same denominator or different denominator, same numerator, different numerator, does not matter. So that's a pretty cool trick. All right, moving on to number 7. I have 5/6 minus 11/24. Again, I don't have common denominators, so I'm thinking I can take that 6, and I know if I multiply it by 4, I'm going to have 24, because 6 is a factor of 24. I'm going to do the same thing to the top, and now I have 20/24 instead of 5/6. And I can now do the subtraction that I wouldn't have been able to do before because I have common denominators. 20/24 minus 11/24 is going to give me 9/24. And for number 9, I have 0 and 3/10 minus 0 and 2/100. Remember, you can add zeros on so you have the same number of digits in both numbers, and then do the subtraction. 0 minus 2, I can't do that. I'm going to have to borrow. Borrow from my 3, bring over the 1. 10 minus 2 gives me 8. 2 minus 0 is 2. Of course, 0 minus 0 is 0. And I bring my decimal point straight down, and I end up with 28/100. Okay, the takeaways. First, when you're comparing fractions with unlike denominators, you have two options. One option is to use equivalent fractions to rewrite them so that they have the same denominator. So make it so that they have the same denominator. Multiply, the numerator and the denominator by the same number and see if you can make it work. Or a really cool way is to cross multiply and just compare those products. Remember, when you cross multiply, you want to start at the bottom and go up. You may want to write this in your notes. For adding and subtracting fractions, you're going to have to rewrite the problem with equivalent fractions so that they can somehow get the same denominator. That's the key. Find a way to get the common denominator. And then you can add or subtract like you normally would. Make sure your answer, of course, is in simplest form. And finally, adding and subtracting decimals. Line up your decimal points, add zeros, just like we've done before, and then add or subtract like usual.